Two ordinary fair dice are thrown repeatedly. On each throw, the score is the sum of the numbers on the two uppermost faces. The probability that the first score of 4 is obtained earlier in the sequence of scores than the first score of 7, and the first score of 7 is obtained earlier than the first score of 5, then is A over B, where A and B are relatively prime positive integers. So, we should start off by, I just want to see something. Wow. So let's say that we have so for the score of 4, we can have 1, 3, 2, 2. And then there are, out of the 36, we have 1, 3, 2, 2, and then 3, 1, 2, 2. Right, because there's 6 and 6. So 4 out of 36 is 4. Or 1 of 9. No, I'll leave it as 4 out of 36. 1 of 9. First score of 7 is 1, 6, 2, 5, 3, 4, 6, 1, 5, 2, 4, 3. So there's 6. So this is 6 out of 36. 1/6 goes to 7. And then 5 is 1, 4, 2, 3, 4, 1, 3, 2. What the heck? This is 7 is the most likely. 1 below 7, 6, 1 above 7, 8 are equally likely. 2 below 7, 5, 2 above 7, 9 are equally likely. So y oh, you can't flip 2 and 2. This is 3 of 36, or 1 of 12. This is 4 of 36. 1 of 9 goes to 5. So there is I don't understand, because, like, can't we just have, like, infinite scores that are none of these? I don't get it. The probability that the first score is if we add all these together, we get 13. So the probability that this is none is 13 out of 36. The probability that we get a 7 is 6 out of 36. Probability that we get a 5 is 4 out of 36. The probability that we get a 4 is 3 out of 36. So if this is NA, then we do this times whatever follows. So I don't know. Okay, so the next one, if it's this one, then we throw it out. If it's this one, then we throw it out. Okay. Okay, so now we do the same thing again. Then we do the same thing again. Okay. So the probability that we throw it out is going to be, I don't know, the probability that we actually get it is going to be 3 out of 36. Then we have to get, gosh, but it could be 13 out of 36 times this however many times we want. I don't get it. Like, one thing that we could get is 4 is NA, 4 NA, 5, or 7, 5. Or we could get 4, 7, 5. Or we can get 4, 7, NA times 200, 5. It must converge somehow, maybe. Like, does it have to be consecutively? I don't get it. I swear I've done a problem like this before, where it's like you can repeat like this, but I forgot how I solved it. I think maybe it's a convergent geometric series. This one right here is 3 out of 36 times it's 3 times 5 times 7 out of 36 cubed. Ooh, something interesting to note. This is equivalent to 4 NA times 2, 7, 5. The numbers NA's doesn't count. So I think we just need to multiply this by the sum, or the product? So it's this times 13 over 36 plus 3 times 5 times 7 over 36 cubed times 13 over 36 squared. Yeah, so it's a sum. I don't know what it's talking about. So it's 3 times 5 times 7 over 36 cubed times the sum from 0 to infinity of 13 over 36 to the n. Okay, interesting. So, this is going to be 1 over 1 minus 13 over 36, which is going to be 7, 10, 23? No. Yes. So it's going to be 23 over 36, or 36 over 23. Okay. So our answer is going to be 3 times 5 times 7 times 36 over 36 cubed times 23. So we need to cancel out this 36, this goes to 2. So then we have 3 times 5 times 7 over 36 is 3 times 12 times 36 times 23. the 3's cancel out. This goes to 35 on the top, and this is a huge number on the bottom. This is going to be 12 times 36 is 360 plus 72 is going to be 432. I think, right? Let me double check. 360 plus 72 is yes. And then we need to multiply this by this, which is going to be 8,640 plus 8,640 plus 1 6 at the end. It's going to be, and then 90 and then 200. It's going to be 8,640. Yes. So 6 9 9 9936. Adding these two together, I'm very sure this is incorrect. So, now the sum of these is going to be 9971. Let me check. No, I actually got it incorrect, but that was a very interesting problem. What they said is that any of the rolls are equally likely to happen, given that they're symmetric. So if we say out of the 13 interesting rolls we have, which we have here, out of these, there is a 3 out of 13 for the first one of these rolls we get to be this one. Then out of these last two, there are 10 left. There is a 6 out of 10 probability. Right, that's 1, 2, 3, 4, 5, 6 out of 10 probability that the second roll is this, and then we're good. I don't even know why I included this. Maybe it would have been correct if I didn't include this 4, because if I don't include this 4, then, because I know it's going to be guaranteed to have a 4 at some point, so I can get rid of this 7 here, I can get rid of a power of 36, goes to 2. This is rid of this goes to 2. This goes to 1. That we get rid of this. Get rid of this. So then we have 5 over, yeah, this is still definitely not correct. It's kind of closer. It's going to be 230, 266. It's not correct, but it's closer. And then, wait, let me make sure this is going to be 3 out of 5, so it's going to be 9. Yes, that's still not correct. I don't even know if I'm doing wrong. I don't know. Anyways, I got it wrong. Cool. Thank you guys for watching. I'll see you guys tomorrow. Bye.